Okay, we're on Unit 11, Lesson 3, using properties of exponents to solve for x. Basically, these are equations. They're equations that you wouldn't have been able to solve if you hadn't just reviewed all those rules of exponents. Okay? So we're going to basically remind you about those properties of exponents, make sure you're good at those, and then show you how to either use change of base or use some exponent properties to solve things. All right, so just real quick, we're going to fire through a few of these. What's that? X to the fifth. And in that scenario, you would add them. This would be, the numbers go with the numbers, and the letters go with the letters. I know they're variables, but what's going to be? 10, x to the fifth. Good. Moving on. This one, x to the 12th. You multiply them in that scenario. Okay. How about here? X to the third. How about this one? Either 1 over x to the fifth or x to the negative fifth. And which one, why can't you say x to the negative fifth? Yeah, we don't have negative exponents. Okay? We're not supposed to leave answers with negative exponents. I know it seems strange. I mean, it is a right answer. This is a correct answer. It's just in a form we don't like. Okay? And it's the same as this, so we want you to use that. Okay. Simplify without negative exponents. In other words, make this the same except without the negative exponent. Turn it my way and let me see if you have it right. That's it. Yep. Yep. Everybody's getting it right. 1 over x. Good. All right, moving on. This one, same idea, just a little twist, and don't have to show me. 1 over what? X to the third. Another way I told you about is they're always fractions because you can put them over 1. And then you can say this isn't happy where it is. Move them to the other side, and now it'll be 1 over x to the third. All right. Rewrite this with an exponent. There's 2 ways. Write both. Yep. I don't want to check all of these. It's hard to read the little exponents that you're writing and stuff. So I'm going to ask you to try to get both ways, and then I'd like you to compare them with somebody that pair you with. We're going to go like this. It's U2, 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 and U2, 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 and U2. Okay, and then it's U3, and it's U3. Compare with each other. Go. See if you get the same thing. Okay. Would you agree you could say this is 4 to the what? Negative 1. Okay, or 2, this 4 could be replaced with a 2 squared, right? To the negative 1, which then means 2 to the negative 2. That's another way to say it. Okay? Yes, sir?
Could you put like 1 over 2?
1 over 2 squared. That is rewritten with an exponent, but it's kind of cheating because it's still in a fraction. So when we say we would, although you did write it with an exponent, we're looking for a base and an exponent only. No 1 in there. Okay? So that and that. All right, moving on. 16 could be, there's two possible ways you could do it. Mr. R squared, what do you think? 4 squared, or 2 to the 4th. Very good. All right. This one, solve this. We've practiced this so many times. Hopefully this is just like, oh my gosh, easy. But some people are going to forget. There's more than one answer. Plus and minus 4. Now I want to make sure you understand why. Some people totally don't get this. They think you go square root and square root, And the answer goes like this. Square root of x squared is x, and the square root of 16 is both plus and minus 4. Total lie, not true. Square root of 16 is 4. So then how on earth can it be 4 and negative 4? Because the square root of x squared is the absolute value of x. That's why. Okay? The square root of 16 is not two things. You try it in the calculator. You ask what the square root of 16 is. It should say 4 and negative 4. If it's both, it's not. It's just 4. Okay? So it's this part. The absolute value then gives you two answers. X equals 4, x equals negative 4. All right, so I'll make sure you understand that. So that's why when you have a problem like this, x plus 3 equals 2, that you can have two answers because the absolute value is splitting into two parts. X plus 3 either equals 2 or x plus 3 equals negative 2, and you solve your two equations. That's why you get two answers. Okay, moving on. Definition of a rational exponent. The power of a property shows that, okay, whew, heavy duty. Let's read through this though, because in the real world, you can end up like in college looking at stuff like this, and the teacher isn't around to explain it to you. So let's just kind of piece it together. A to the m over n, that's a fraction power, equals 1 over n times m. Okay, so they just split this up into a fraction. And m 1 over n. All they did is reverse these two. Okay, so they're taking fraction powers and breaking them into two parts. So a to the m over n is equal to the root of a to the m. And that was like I was saying yesterday, that the roots are on the bottom. When we have a fraction thing, the roots are on the bottom. See, this is the root, and it came from the bottom. Or, if you have the same problem, the root, this is the root, is here, and the other power right there is here. And this is saying that you could either have the power m on the outside or on the inside, and it doesn't matter. In other words, you could do it first or you do it second, and it doesn't matter. Okay, so let me give you an example to make sure you understand that. If you have 8 to the 2/3 power, remember me talking about the roots are on the bottom? Did I mention that yesterday? Okay, good. So then this is there's two parts to it. You do the root, and you can do the power. Now I could have done it this way, 8 to the second and then to the 1/3. But then obviously one of these is easier than the other. To me, it's easier to make it smaller first and then square it than to make it really big by squaring it and then try to find the root of it. You can do it in either order. It's rare in math that you can, hey, order doesn't matter. Okay, but on these kind, order doesn't matter. You get to pick, but I'd always make it smaller first before I made it bigger. All right, so 16 to the 3/4, oh wait, I suppose I should finish this. I'm going to do it the way I said was smarter and make it smaller first. The cube root of 8 is 2, and then it becomes 2 squared, which is 4. So the answer to this question is 4. Okay? This one's the 4th root of 16, which is what? It'll work better if you say these out loud. What's the 4th root of 16? 2. And then 2 cubed? 8. See how I did this, the bottom first and then the top? So this was the 4th root of 16, which means what times what times what times what? What four things multiplied the same thing would give you 16, and that's 2. So it's 2, and then you put 2 to the 3rd is 8. Would you do the last 3 of these without me and check with the other kid next to you? Always do the root first. Roots are on the bottom, and I'm telling you, your life's a lot easier if you take the root first and then put it to the power. In case you forgot what 2 to the 5th is, it's going to come up, and it's 32. Okay, try these three. Check them with the person that I paired you with. I'm going to pause for a second while you do that. There we go, checking out these answers here. 32 for this one, 16 for this one, and I'll show you how to do this one. The cube root of 27 is 3, because 3 times 3 times 3 makes 27. And then 3 to the squared is 9. All right, 32, 16, and 9. Raise your hand if you had those right. Okay, good. Let's move on then. How would you solve this equation then? Well, you got to make the bases the same, just like we did yesterday. Oh, wait a minute. I can't pick anything I want for x and make the bases the same. That's not gonna work this time. That's what we need to do differently today. Is you can't always solve them by making the bases the same. It's a great way to solve things. It won't always work. Okay, so I need to somehow get x alone. That's what you're doing when you're solving, right? It's trying to get the x alone. All right, so why isn't the x alone right now? It's to the 2/3. How do I fix that and make it so it's not to the 2/3? I can get rid of the 2/3 by putting it to the power of 3/2. There we go. That's why we just practiced all those fraction exponents, because, look, we have to use it now. Now, this is important. Notice in the notes it says, don't lose a solution. What the heck are they talking about? Do you remember how when you take the square root on both sides, you end up needing to get two answers, plus it and minus it? Just went over that with like x squared equals 16, and we did. Remember, it's not just 4. It ended up being plus and minus 4. It's a long process that involves absolute values and whatever. I bet you that very few people would have noticed that we just did the square root on both sides, didn't we? By doing this, by putting it to that power, we are forcing a square root to happen on both sides. All right, so now the simple stuff that happens is the 2 cancels the 2, the 3 cancels the 3, and then I have x equals whatever 4 to the 3 halves is. Okay? But you've got to remember you have plus and minus that. Because technically we had the absolute value of x here. When we did the square root on a variable, we have the absolute value of it. So that's going to force us to get x equals plus and minus of this answer. We just did a bunch of these. Square root of 4 is 2. 2 to the 3rd is 8. So it's plus and minus 8. Now, why didn't we say plus and minus 8 back here? Because this wasn't taking the square root of a variable. Do you get the difference? These are only the positive answer. This is like saying, what's the square root of 4? And the answer is just 2. You don't get 2 answers. How come you get 2 answers on these kind then? Because they are variables. And there's a variable in it, and therefore when I square it both sides, which is what this little divide by 2 thing is, you square rooting a variable over here, and you end up with the absolute value, and therefore it's plus and minus 8. Can you imagine how a lot of kids are going to forget that? Very easy to miss. Because you're going to just think, oh, easy, I just put it to the 3 halves power. And then you'll get 8, and you'll forget. Plus and minus 8. Okay, here's another one. Now on this one, when you put it to the 1/3 power, you are putting it to a root, but you're not putting it to a square root. Why does that matter? Because when you put it to a cube root, there's nothing wrong with doing the cube root of a negative. Let me just show you that for a second. The cube root of -8 is just -2. But whenever you do a square root of a negative, like the universe folds inside out and everything collapses. Can't do square roots of negatives. It's impossible. It opens up a singularity. So anyway, back to cube roots of negatives are no big deal. Because -2 times -2 times -2 makes -8. So cube roots, you don't have that issue of needing a plus and a minus answer. All right, so when I do the cube root, I don't worry about getting 2 answers. There's not 2 answers. There's only 1. All right. So let's figure out what the answer is. Cube root of 27, which is what? 3. So if 3 is really the answer, let's put it in. 3 to the third is 27, right? Do you get why if I tried to use negative 3 as an answer, it wouldn't work? If I tried x equals negative 3, I stick in a negative 3 here. Negative 3 times negative 3 times negative 3 is not 27, right? So you can't just say, well, this doesn't make sense. The other ones, sometimes you do it, sometimes you don't. This makes sense. You can't use negative 3 because negative 3 would give you an answer of negative 27. So it's only one answer on this kind. So what do you have to watch out for whenever you are doing a square or an even root on the bottom? You do that to both sides of an equation. You got to make sure you have a plus and a minus on your answer. Okay? But this is an odd one, so I don't need the plus and minus. It's just 3. Okay. Moving on to this one. We got to make that power into a power of 1. So I'm putting this to the power of, and this to the power of 3. Good. And then that's 3 over 1, right? So then this cancels this. And did I do an odd? Technically, since it's to the power of 3 over 1, do you get I'm doing an odd root? I'm doing the first root of it, which is itself. So anyway, so I don't need to worry unless that's an even number down there. And it's not, so it's just one answer, and the answer is 3 to the third, 27. And again, these are nice because you can always check yourself. If you think it's 27, you go back and you stick a 27 in, see if it works. Is 27 to the 1/3 power equal to 3? Yep, it is. So I know I did it right. Okay, moving on to this one. X to the 2/3 minus 8 equals 1. It's not that complicated. You just need to get the clump alone. Remember that saying? This is the clump. Get the clump alone. Adding 8 to both sides. Now, Maddie, when I do this, is this one the kind I have to worry about or not? What power am I going to put it to? So should I be worried or not? Yes, I should. Because I just did a even root. That means I have absolute value of it is, and then a square root of 9 is 3, and then the 3 to the third is 27. And if you had just said 27, you'd have had it wrong. Plus and minus 27. How many of you caught that? Good. Whenever you do an even root, you'll have 2 answers. Okay. Try this one without my help at all. A lot of people are going to make a mistake on this one, and I'm interested to see who argues correctly. I'm going to pause for a minute. Check with your neighbor that I assigned you. Okay, I want to put the arguments to an end. I was hearing some good arguments. Some people arguing vociferously the wrong way, but we'll see if you were arguing the right way or the wrong way. I'm taking away 8 from both sides. Okay, I hope you got the clump alone. X to the 1/4 equals 2. I'm sure most people got there fine. Then you put it to the power of 4 on both sides. So I ask you, did I take a square root on both sides? No, I did not. There was no root, and therefore there is no issue of worrying about plus and minus. The final answer is just 16. That's it. Okay. And don't feel bad if you were arguing the wrong side of it. Just learn from it, and it's no big deal. I make mistakes all the time. So I'm going to add 7 on both sides to get the clump alone. And then this big clump here needs to get fixed in a minute. 3x minus 3 to the 3/2 equals 27. Okay. Now on this one, please get into the problem at this step if you weren't before. Some of you are sitting there with your arms crossed. I need you to be with me. Solve this one by putting it to the power of 2/3. Now I ask you, did you just do an odd or an even root on both sides? Odd root, so we don't have to worry about the absolute values coming in. Okay? If I had just done an even root, I would have to done absolute value of 3x minus 3, which would be a totally different answer. I had to break it into two parts and do that whole thing. But I just did an odd root on both sides, therefore I don't do that. Then this just cancels this, and now I'm down to 3x minus 3 equals root. The third root of 27 is 3. 3 squared is 9. There we go. And now it's child's play from there. Add 3 divided by 2, no big deal. So it's kind of a get the clump alone theme again, because you got to get this off of there first, then you can put it to the power that gets rid of this, which is to the power of 2/3. And if it's an odd root down there, your life's a lot simpler because there's no absolute value needed. Okay. This one, again, a fairly simple one. Give this one a shot. This one shouldn't be too hard. Get the clump alone. This. Okay, so we start by adding 5 to both sides. We got the clump alone. This is the clump. To get that fixed, I have to put it to the power of 2. Power of 2. So then that just cancels that off. I did not square root both sides, so I don't need absolute values. 2x minus 4 equals 49. From there, it's easy. Subtract 4, divide by 2. I think you get 22. Is that right? Okay, that's what you get when you try to do in your head. All right, add 4 to both sides makes 2x equals 53. You're right. What I did is subtracted 4 from both sides. Bah. All right, so that's why it's good to show your work. Divide by 2, divide by 2. X equals 53 halves, or half of 53. And I'm fine with 53 halves as a good, perfectly good answer. You need a decimal. Let me see, it'd be 25, 26 and a half, if anybody did it that way. Okay. All right, this one. Remember to check your answer. A lot of times on these, you should profile these. Okay? Profiling is in an airport is bad. I actually agree with this. If you only check people who look scary, you could easily have somebody walk onto the plane who is, you know, like the grandma in the wheelchair. I know, pretty unlikely grandma in the wheelchair is smuggling in an explosive. But if you just don't check grandmas in wheelchairs, pretty soon that's who they're going to use to explode the plane. You know what I mean? You have to check everyone. You can't just pick people. But in math, you should profile certain kinds of problems to double check. Because whenever there's a square root, there's a much higher likelihood that you're going to have a problem with them. Like the answers you get sometimes just don't work. Like you get an answer and you stick it back in and it doesn't actually solve the problem. Okay, so check this one that way. While I'm collecting these scores over the next few minutes, I'll pause the video here, but I want you to try solving this. I hope you can tell that you're going to get rid of the square roots. How are you going to get rid of the square roots? What's the opposite of square root? Squared. Because do you get it's the exact same thing as if they had said this, 3x plus 2 to the 1/2 power, because that's what a square root is, right? So there are square roots on each of these, and you're going to get the square roots fixed by squaring them. All right, give it a shot. Square both sides and then solve it down and get an answer and then double check it. Make sure it actually works. I'm going to pause while you do that. All right, if you checked your answer, I'm guessing you found that something didn't work. All right, did anything actually work? Did anybody find an answer that they want to stand behind and they say, I think the answer's 6 or whatever? Okay, then you're right. And let me show you why I know. Because when I do this square root over here, do you get that the answer will have to come out a positive number? When you do a square root, it has to come out positive. It just has to. Square root of anything never comes out negative. So how could it equal a negative something? Can't. It's impossible. So this one has no solution, and I can tell just by looking at it. Now, the question is, will you be able to tell just by looking at the problem whether or not it's got a solution or not, okay? Because I'm kind of experienced in knowing what to look for. Okay, so this one. This is a base change one. Get them both to have a base of 2. And then the powers will have to be the same, and it'll be easy. Do you have 2 to the 4th? Good. Then 2x has to equal 4, so x must be 2. Raise your hand if you had that one right. Okay, good. Now, what if your life depended on it? How would you check it? Put the 2 back in and see if it actually works here. 2 times 2 is 4. 2 to the 4th is 16. That makes sense, right? I double checked it. Now, if I was doing a Marzano style test, I only had 8 questions. I'd probably double check every single one of them because there's only 8 questions. What if there was only like 3 that even had the chance for me to check them? I might as well check them on a test, right? If I were you on your next test, I would be double checking because it doesn't take that long and you can know if you're right or not. Okay, here's the common mistake people were making last time. They weren't keeping this equal to the thing they substituted for it. This has to be exactly the same as whatever you put in for it. Okay? Try to be careful about that. If you want to keep it the same, you can. Maybe you're going to use 1/4 as your base. You could. Or you could make this into a 2. But if I just put a 2 here, that's not equal to 1/4. I can't just make that substitution because 2 and 1/4 are not the same thing. But I could make it a 2 to a power, for example. All right, try to solve this one. Make sure that what's right underneath each thing stays equal to the thing above it. If you're struggling, try to make them both into 2s. Both of them can be a 2 to a power. I'm going to start on this right side. I would say 2 to something makes 16, and I would do it in 2 parts because there's the flipping part, and then there's the how do I get the 2 to turn into a 16 part. Okay, so I would say 2 to the 4th gets me up to 16, but 16 is not the same as 1/16. Now I need the flipping part, -4. Okay, this other one, how do I get a 2 to turn into a 4? By squaring it. But then they're not the equal to each other, right? So I got to make it -2. Now I double check it. 2 squared is 4, and then I flip it 1/4. Yes, this is equal to the thing above it. And since these both have the same base, that must equal that. -4x equals -4x equals 1. Raise your hand if you had that one right. Okay, good. All right, I think we've got enough practice on those. Here's one that's on the very first few questions of the homework. X and 3. When you do a 4 like that, what do you do with those 2 powers? Do you add them or do you multiply them? That becomes 4 to the 3 plus x equals 4 to the 7. Do you get now I have the same base on both sides? And therefore that equals that. And it's a super simple equation. What's x got to be? Yes, sir. Good question. When we had a to the 3rd and a to the 5th, wasn't that just a to the 8th? I didn't say a squared to the 8th, did I? All right. Here's another way to think of it. Let's say I take this 4 to the 3rd times 4 to the 2nd. That's going to be 4 to the 5th. Why is it 4 to the 5th and not 4 squared to the 5th? Because 4 to the 3rd means 4 times 4 times 4. 4 to the 2nd means 4 times 4. And what am I doing between them? Times. That's why it's 4 to the 5th. Do you get how I didn't need to square them? Okay, hold on. Back to this. Your question really came down to when I put these 4's together, why didn't I square them? It's because all you need to do is add the powers in all of these situations. You didn't ever square them and then add the powers. Okay, go ahead. Okay, so you have to, and to some extent, I don't want you to just trust me. That is a terrible math reason why something's true. Okay, I needed to prove it to you, but you can trust examples, like when you do it this way and you do it this way and you do it this way and it all comes out where you don't have to square it, then you don't have to square it. Okay, so then this becomes just 3 plus x, or x plus 3, equals 7, so x must be 4. Yes, sir?
He might have been misinterpreting what he said. I think
Okay.
he was trying to say if it's like 4 to the x times, say, it would be 32.
Okay, if it was 4 to the x times 32
Equals 4 to the 7th.
equals 4 to the 7th. Okay, is that what you were going for?
Well, like, when you do like 5a squared b.
Okay, wait. Let me write that down. 5a squared b, you're just giving an example, I like that.
Times like ba to b.
Okay.
You do multiply the 3 and the 5.
You do multiply the 3 and the 5. Why? Because those don't have powers on them, and they are not the same base.
Oh, because it's not directly powered. Oh, okay.
If these had been the same thing, if they had both been 5s, I've never even done that, but if I had, you could have said that it was 5 to the 1 times 5 to the 1 makes 5 to the 2nd, which would be 25. But the simpler way to do it is just go 5 times 5. Okay. All right. Your homework for today. Again, it's been really long work sessions during class, but you've been paying attention really well. I want to, again, do a nice shortish assignment because you did lots already with me. So we're just going to do evens again on your homework. Have a great day.